Friends, how are you? I welcome all in my YouTube channel Enlightened Mind. Today we'll be covering the topic of electric field intensity due to a straight rod carrying a uniform distributed charge. So basically today what we'll cover here is that a particular charge, suppose there is a rod, okay, and that rod is uniform in distribution of charge, and suppose we are asked to calculate a particular electric field intensity at a particular peak which is passing through the axial line or a plane perpendicular to the plane of the uniform distributed charge of the rod. So suppose here that point is P and we are asked to find the electric field intensity due to this uniformly charged rod at point P. So let us, for that we consider a particular segment of the rod. Suppose this is the segment of the rod whose length is suppose dy, and the distance of this point from the rod is x, right? So this particular um, portion of the rod would have a charge. Suppose q is the total charge of the rod, okay? So surface charge density, or the linear, here in this case is the linear charge density. So when you divide this q with this length, suppose L is the length of the whole body, suppose that is the L, and suppose this L suppose is 2a for the sake of simplicity. So this side would have this portion would have a length small a, and this portion would have a length of small a, right? Half above and below this particular point. O, suppose O is the middle point of the rod. So this portion would have a particular suppose particular charge, and that charge suppose is dq, okay? dq is the charge of that particular point. So first of all we need to calculate what is the charge density, which is lambda. Lambda is the linear charge density that has to be divided by the length of the rod, and here the length of the rod is twice of a, okay? So you can write lambda is equal to charge, which is q, divided by length, which is 2a, right? But this is the charge at a particular point, and we are interested to find the charge of this segment dy. So that charge suppose is dq, and that would be equal to lambda, which is the linear charge density, and has to be multiplied with the length of that particular segment. So dq would be this one. So lambda here in this case is q upon 2a, and dy, that would be your dq, right? So the electric field intensity at point P due to this segment would be suppose dE, and that would be 1 upon 4 pi epsilon naught divided by distance of that particular segment, and that distance suppose is r, and that would that is the hypotenuse of this triangle, okay? So this r should be, if suppose that length is y, suppose that length is up to this point, that is y, so that would be y square plus x square under root, right? So the dE, that is a small electric field density due to point at point P due to this segment dq, dy would be dq. dq is the charge of that segment, which we already have calculated. This is the charge of segment dy, divided by the distance between the point P and this segment, which is square of the distance, which is this, okay? And it should indicate to a particular point, suppose particular direction, that is the direction which is r cap. R cap is the direction at which this electric field intensity D is directing, right? Now our task is to find this electric field intensity, okay, which is very simple. Suppose if this uh, point P, or the electric field, is making an angle theta with this line, so this dE can be divided into two portions. One is along x-axis, so dE along axis, and dE along y-axis. So that would be dE into cos theta, and here dy would be dE to sine theta, okay? Very simple. So you can put these values. So dx, dE along x-axis would be dE into cos of theta, with electric field intensity due to y at the y-axis, okay, y segment would be dE into sine theta, right? So our task is to find the electric field intensity at because of the x-axis and because of the y-axis that we will try to calculate. So suppose total electric field intensity due to uh, x-axis, okay, that E along x-axis should be, we have to really integrate dE along the x-axis, okay, um, and of course along the y-axis, of course, okay. So initially the rod was having this much of distance, which was dy, okay, and this particular segment was experiencing or exerting a force dx, and the electric field along x-axis was dE into cos theta, okay, and that was because of that portion only, okay. And if this length is 2a, so if it is 0, suppose, so that should be minus a and that should be plus a. So the length is from minus a to plus a, okay. So basically limit should be from minus a to plus a, okay, and that is because of this particular portion only. So just you have to put this value here and dx is basically dE into cos theta, okay, and limit is from minus a to plus a, right? So you have to put these values. So dE basically here is, we already calculated 1 upon 4 pi epsilon naught dq upon this much r square, and which we already calculated was x square plus y square, okay, that was x, and that portion from here to here was basically y, and that was the angle theta, okay, and cos theta of course is there because of this portion, okay. And we also calculated that this dq was basically lambda into dy, which later on was written as q upon length 2a into dy. So you can put this value here, and of course integration from minus a to plus a. So that could be written as integration from minus a, that is the limit from minus a to plus a, and 1 upon 4 pi epsilon naught, that dq was actually lambda upon dy, and in denominator that was x square plus y square, and cos theta can of course can be written as base upon hypotenuse, which is nothing but base is x and hypotenuse here is x, r basically, that is the hypotenuse, and r is nothing but square root of x square plus y square. Very simple, okay. So let us now just try to solve this further. So you can take constant terms out of that integration sign. One of the constant term is this, okay, then lambda, that's all. So you can put 1 upon 4 pi epsilon naught outside of that integration sign, then lambda. These are the terms you can take out of that, and x is also you can take out, because when you vary the length, okay, from dy from minus a to plus a, so only y would change but x remains constant, okay. Theta would also change but x would remain constant. Because of that reason x can be taken out, because here x is constant, because x is the distance from 0 to point, suppose p, where electric field intensity is to calculate. So in that sense this particular x distance from the origin of that rod, or the middle point of that rod, is same, okay. So that can be considered as constant, so I can take x here out of that integration sign, okay. So limit is from minus a to plus a, and other terms which is not a constant can remain here, which is dy x square plus y square, and then another square root term x square plus y square, okay. So that can be written as 1 upon 4 pi epsilon naught lambda into x minus a to plus a into dy by, so this basically has a power of 1, and that is half, so that can be written as x square plus y square's power 3 by 2. Okay, very simple. Now here two terms are there in the denominator, one is x and other is y. I already said that this x is basically a constant term. So uh, in the diagram here we have x and here is y. So basically y can be written in the form of x and theta is basically changing. So you can write that y, which is the perpendicular and that is the base, can be written as tan theta in this diagram. So y you can write is equal to x into tan theta. So basically we are denoting y in terms of x, and x is a constant, okay, and theta is basically changing. So likewise dy can be written as x is a constant term, and when you differentiate tan theta with respect to theta, so that becomes sec square theta into d theta. Okay, so you can also replace dy in the equation here dy and this y with this particular term. Okay, so you can write here that this y is basically x into tan theta. Okay, and this x basically dy can be written as x into sec square theta into d theta, right? So you can put these values here in this equation, and also you need to change this limit. Okay, but when you see this particular thing, you can see that basically this is a function of y and x, and this function can also be written as fxy, which is the function of here, and that is a dy. Okay, minus infinity to plus infinity, sorry, minus a to plus a, lambda x and 1 upon 4 pi epsilon naught. So here where this function fxy basically is 1 upon x square into y square ki power 3 by 2, and this function is an even function. Okay, so whenever there is an even function is basically the function when you put the value of x or y anything here, so the sign of that function remains the same even after changing the sign of this thing. So if I'll suppose change the sign of y here, so that would remain same. That is an even function, and there is a property if suppose there is an even function plus a to fxy or fy or fx anything, and if this is an even function, okay, if this is an even function, so in that sense, or in that case, that can be written as 0 to a fx y dy and 2 twice. Okay, so that function now can be written as in the following fashion. So that can be written as lambda into x upon 4 pi epsilon naught, and limit is from minus a to plus a fxy to dy, and I already said that this is an even function, so that can be written as lambda x upon 4 pi epsilon naught 0 to a, and here 2 would come, fxy to dy. And what is this fxy? That is 1 upon x square plus y square to power 3 by 2. Okay, that is the function, and that is the dy. So that becomes from 0 to a, and here you can write all these things. So 2 lambda x divided by 4 pi epsilon naught. So this particular thing can be written, I already said that y can be written in the form of x, which is x tan theta. So dy can be written as x into tan, so that becomes basically sec square theta, okay, into d theta. So you can put this value here, and also this particular limit would also change. Okay, so when you put this equal to this, and if you put particular value of y, so that limit would also change. Okay, that is very interesting, you can see it. Okay, So that particular thing can be written as 2 lambda x divided by 4 pi epsilon naught. So you can put this value here, in this case 0 to a, and dy is basically x into sec square theta into d theta, and when you put this value is equal to x into tan theta, that becomes 1 plus tan square theta. Okay, and you can take x common, x square, and that is 3 by 2. Okay, so that basically would be 2 lambda x 4 pi epsilon naught, and that become x. So you can, that basically become the x cube. Okay, because x square 1 by 2 would cancel out and cube would come out, so x divided by x cube. Okay, and that basically is sec square theta into d theta. So tan square theta, 1 plus tan square theta would become sec square theta. So that basically is sec square theta, and outside power is 3 by 2. So that basically this 2 would cancel out, so 3 would remain. So the final term would be 2 lambda x divided by 4 pi epsilon naught. And here this x would cancel out, so that would become x square in the denominator, and that would be sec square theta divided by sec theta, sec cube theta basically. 2 would cancel out, and d theta, and that is from 0 to a limit. Okay, now that is very simple. You can cancel out some of the terms, and that become 1 upon sec theta. So that becomes 2 lambda divided by 4 pi epsilon naught. One of the term x square, 1x would cancel out, so only x would remain, and that is from 0 to a, and that would 1 by sec theta into d theta. So basically this 1 by sec theta can be written as cos theta. Okay, so the electric field along x-axis would come out to be 2 lambda divided by 4 pi epsilon naught into x, and limit is from 0 to a. Sec 1 by sec theta basically become cos theta into d theta. Okay, and you know that cos theta basically is what? When you integrate that cos theta, become sin theta. Okay, so that become sin theta. Limit is from 0 to a, 2 lambda 4 pi epsilon naught into x. So the interesting point here is that this a is the limit from when y was replaced with x into tan theta. So that basically not in terms of theta. So that limit would also have to be changed. That we'll try here now. So now let us consider that when we considered that y is equal to x into tan theta, and the limit was from 0 to a, right? So when we'll put a is equal to 0 here, so in place of y, basically y is equal to 0 here in this case, because limit is from y. Okay, y in the form of y, so that can be written as 0 is equal to x into tan theta here in this equation. So x, basically tan theta would be 0, so theta would be 0. Okay, in this case limit would be from 0, means if you change this limit, that would become 0 to that limit would be 0. Okay, but when we'll put y is equal to a, because here y is 0, y is a, so that equation y is equal to x tan theta could be written as a is equal to x into tan theta. Okay, that is very important. So a upon x would be your tan theta, but we know that tan theta is nothing but perpendicular by base. Okay, so if you make a triangle here, so that is your perpendicular, okay, and base. Okay, and of course that is x, and that particular p is a. Okay, right? So our task is to find this particular thing, okay, which is hypotenuse. So hypotenuse, why we are calculating this? Because we need to know what is tan theta, sin theta here in this case. Okay, so this hypotenuse will be perpendicular square plus base square root. Okay, so here p, which is the base, here is a, you can write a square, and base here is x, which is x square, square root. So your sine theta then would be perpendicular by hypotenuse, which is perpendicular here is a, and hypotenuse here is a square plus x square. So that is your sine theta. So you can put this value of sine theta here in this case. Okay, so that would no more remain in form of theta, that would be changed in the sense, in the way this can be written. Okay, so that would be 2 lambda upon 4 pi epsilon naught into x, and sine theta when a, means you can put sine theta, okay, when theta is a, minus sine theta when theta is 0. Okay, but when we know that when theta is 0, limit is 0. Okay, so you can put straight way here 0, so sine 0 here is 0. But sine theta when theta is equal to a, you have to put here theta is not a, basically theta is this one. You can calculate theta here from here. So theta would be tan inverse of a upon x. Okay, here, so that would be tan inverse of a upon x, right? So we'll do it separately now. So electric field along x-axis could be written as 2 lambda divided by 4 pi epsilon naught into x, which is sine theta, right? When theta is equal to tan inverse of a upon x, right? And minus sine theta when theta is equal to, theta is 0. Okay, so that basically is 0. But this can be written as sine theta when theta is equal to this, we already calculated what sine theta is. Sine theta we already calculated was a divided by a square plus x square under root. Okay, so you can put this value here. So that would be 2 lambda upon 4 pi epsilon naught into x, and sine theta here is a upon a square plus x square. Okay, and that is in square root. So you can put this value here. So that would be 2 lambda into a 4 pi epsilon naught into x, and the square root of a square plus x square. Okay, that is the final answer. That is the electric field along x-axis. Similarly, electric field along y-axis can be calculated. You can also replace this value of lambda, which is what q divided by 2a. Okay, so when put 2a, that 2a would be cancelled, only q would remain here. Okay, so that would be 1 by 4 pi epsilon naught. Okay, 2a would be cancelled out, only q would remain, x would remain, and a square plus x square would remain. So that is the electric field along x-axis. Similarly, you have to calculate along y-axis. So along y-axis that would be 0. That is very easy to see. Okay, so when we see an electric field here, suppose that what we had done earlier, so that was the electric field on because of the element dy on the upper side. Similarly, suppose there is another element dy along in the lower portion, so that would also exert an electric field along this direction. Okay, so these two would added up here. Okay, but here this would be along y-axis. So the electric field along y-axis, because the smaller portion is the lower, would be cancelled out by the electric field intensity along y-axis because the upper portion, right? So these would be cancelled out. They would be equal and opposite. So you can say the electric field along y-axis would be 0. Okay, that is very easy to calculate. So if you like this video, you can please click on the like button and subscribe my channel if you hadn't done it yet. So thank you for watching my video. Thank you very much.